All right, we're going to go ahead and try take 2 here with the Math 1 Unit 5 review. So we're going to start with our sequences. And this is a pretty long review. There's a lot of problems on here, more so probably than we even need. But so I'm going to kind of work this a little bit quickly here. So is the sequence arithmetic? So that means is it changing by addition or subtraction? So I'm going to look here and see. And I will see that it's actually adding 6 every time. So yes, that's arithmetic. Common difference is 6. That's what it's adding every time. So the explicit equations, I'm going to forget about these right here and kind of just do what we were doing. So our explicit equation, t of n equals t of 0. So I actually have to go backwards and find what would go here, the 0 term. Right, so I'm adding 6, I'd subtract 6 the other way. So negative 19 plus 6n. And the recursive equation, t of 1 equals, so the first term, not the 0 term, but the first term, and t of n plus 1, so the next term is the current term plus 6. Okay, so that's kind of how that would work for all those. Again, there's a lot of repetition in here, so maybe we'll look and see here, right? That would be plus 1 plus 3. So that is not arithmetic. That'd be something else. Here, plus 4. So for this third one, 0 to 4 plus 4, 4 to 8 plus 4. So it's adding 4 every time, right? So the difference would be adding 4, which makes it arithmetic. I'm going to find my 0 term. So what would come before this one? So I subtract 4. Fill that in. And t of 1 equals the first term, not the 0 term. The first term was 0. And t of n plus 1 equals t of n plus 4. So you can see how these are all going to be pretty similar, right? 9 to 15 would be plus 6, that'd be plus 10, so this is a no. Right here, 8 to 3, 3 to negative 2, negative 2 to negative 7, those are all going down by 5. So here the difference is negative 5, oops, that's a 4. So the difference is going down by 5. Which makes it arithmetic. Every time was the same. So t of n equals, I got to find the 0 term. So what would come here? So if I'm subtracting 5 that way, I'm going to add 5 going this way to get 13. So 13 minus 5n. First term was 8. Okay, this one is a little bit different. There's a couple ways I could do this. I could, make a table, right? I mean, really what this is, 1, 2, 3, 4, 5, right? I mean, these are the points. If I look, it's 1, 2. All right, that was this one. Then here I have 2, 4. Then I have 3, 6. Then I have 4, 8, and 5, 10, right? So I could write down the coordinates and I can see these are all changing by 2, right? So that's a yes. The difference is plus 2. And I would need to find the 0 term. Well, that's the y-intercept. It's going to be down here, right? So if I subtract 2, I'm going to get 0. So t of n equals 0 plus 2n. I could lose the 0 if I want to. Right? T of 1 equals 2, right? And t of n plus 1 equals t of n plus 2, right? And that's this 2 right here. All right, write the first 3 terms of each sequence, then write the explicit equation. So t of 1 is 15, and this tells me the next term is the current term plus 5. So that means I'm going to add 5 every time, right? So 15, 20, 25, and it asks me to write the explicit equation. So I need to find the 0 term right here. So that means I would have to subtract 5 and I would get 10. So my explicit equation equals 10 plus 5n. Okay, here t of 1 is 7, so it starts with a 7, and then the next one is the current one minus 7. So I'm going to go ahead and subtract 7 all the way across. So this would leave me with a 0, negative 7, on and on. Right. I need to find the 0 term to write my equation, so I'm going to add 7 and end up with a 14. So t of n is 14 minus 7n. All right, number 3, given the recursive equation, write the first 4 terms in the sequence. So no equation necessary, so I'm just going to look here. I know it starts with negative 9. And I know the next term is the current term times 2. So first I'm going to multiply by 2, then I'm going to add 3. So going from there to there, I would have negative 9 times 2, and then I would add 3. So that would be negative 18 plus 3. So negative 15, right? So be careful with your signs when you're adding a positive to a negative. Right? So from there to there, negative 15 times 2 would be negative 30. And then I add 3. And this one asks for 4 terms. So from there to there, negative 27 times 2 is negative 54. And then I add 3, so negative 51. Okay, B is very similar. First term is 16. And then I know that after that, the next term will be the current term times a half. So I'm going to do this first, and then I'm going to add 4. So times a half, then add 4. So 16 times a half would give me 8, and then I add 4. So I'm going to get 12. 12 times a half would be 6, plus 4 would be 10. 10 times a half would be 5, plus 4 would be 9. All right, so I try and make it through all of this on one video. Okay, number 4, given the sequences, identify the following characteristics and values. So I'm going to look to see if it's adding or subtracting. Obviously, these are not adding, whoops, no, the same amount every time, but they are dividing by 5, right? But I don't want division. I want my common ratio that I can use for multiplying, not dividing. So I got to take the right and divide by the left. So if I take the right and I divide by the left, negative 25 over negative 125, the negatives will cancel out and I can reduce to 1 over 5. So my R is 1 over 5, right? Multiply by 1, divide by 5. That's what that fraction means. So arithmetic or geometric, that's geometric. It's doing the same the whole way across. All right, recursive rule. The next term is the current term times 1/5. And I know the first term, should have done this first, is negative 125. So 5th, 6th, 7th term, so the term after the negative 1, right, I'm multiplying by 1/5. All right, and do it again. So really I'm multiplying the bottom by 5. All right, so here, negative 3 positive 6, negative 12, negative 24. So I see the numbers are multiplying by 2. So the ratio would be 2. But they're changing from negative to positive, negative to positive. That means it's multiplying by a negative, right? Because every 2 times the negative cancels. I could check it, right? 6 over negative 3 is negative 2. Negative 12 over 6 would be negative 2. So my r is negative 2. That's in fact geometric. So t of 1 equals negative 3. And the t of n plus 1 equals t of n times negative 2. So when I'm multiplying by a negative here, I want to use parentheses here. If not, it looks like subtraction. And it's not subtraction, it's multiplication. All right, so here it is adding 9 every time, right? So that's arithmetic. So I don't have an R, I have a D. D for difference. And the difference is 9. So recursive formula, first term is 25. And after that, the next terms are the current terms plus 9. And, oh, it didn't ask, well, I didn't do these, but that'd be negative 48. And then positive 96, then back to a negative 92. This one they're adding 9. Oh, I apologize. Subtracting 9. Subtracting 9. So the next one would be negative 11, negative 20, negative 29. All right, so I'm gonna skip one of these, right? But from here to here, from 1 to a half, I could subtract a half. But from there to there, a half to a quarter, I would subtract a quarter. So those are not arithmetic. I could multiply by a half, and a half, and a half, and that would work all the way down. So that's geometric. My r is multiplying by 1/2. So t of 1 is 1. And after that, the next term is the current term times 1/2. So the next one, after 1/8, would be 1/16. And a 32nd, and a 64th. This one is adding 15 every time. All right, it's arithmetic. We've done a few of those already, so I'm going to kind of skip to this next one. Definitely not arithmetic, I can see from the graph here in this bottom one, because it's got a curve to it. So I'm going to actually make a little table, right? So this one right here, that would be 1, 8. This one right here is 2, 1, 2, 3, 4. Then 3, 2. And this one was 4, 1. So 8, 4, 2, 1, I can see it's being cut in half, right? Maybe I couldn't quite see that from the graph, but if I make a table, I can. So the ratio, it's being cut in half, so I multiply by a half. That's geometric. So the first term was 8, and after that, the next term is the current term times 1/2. So after this point down here, right, the next one would be 1/2, then a quarter, and an 1/8. So maybe I'll just try and get through all of these here, formulas for the arithmetic and geometric. So number 5, given the first 2 terms of the sequence being 3, 6, and another term is 24, so these are really ask me to do 2 different things, we'll see. If the sequence is arithmetic, write a recursive equation. So if it's arithmetic, right, that means 3, 6, means it's adding. So it'd be 3, 6, 9, 12, 15, 18, 21, 24, 27, right, keep going. So the recursive formula, t of 1 is 3, And after that, the next term is the current term plus 3. This would be my formula. The explicit equation, right? For that one, I have to go backwards. So I got to find the 0 term, which would be 0. So the explicit equation and what term is 24? Well, right, 1, 2, 3, 4, 5, 6, 7, 8. It's the 8th term. If the sequence is geometric, write the recursive equation. So that means it starts with 3 and then 6. So if it's geometric, it's multiplying, so it's times 2. So that means the next one would be 12, and then 24, and then 48. All right, so term 1, 2, 3, 4, 5. So write the recursive equation. T of 1 was 3. And the next term is the current term times 2. Those two pieces. And then what term is 24? Well, it was 1, 2, 3, 4th term. Which sequence has a larger 10th term? Can you justify your answer without calculating? Well, I don't know what they mean by calculating. I could keep going. Right, I already see here on part A, right, that was the 8th term, the 9th term. I mean, the 10th term would be 30, right? And over here, right, these are doubling every time, so they're going to keep getting bigger. It's already bigger than 30, so right, the geometric sequence grows much faster. All right. Last one I'm going to do on this portion of the video is number 6. Given the sequence 3, 3, 3, 3, answer the following questions. Is the sequence arithmetic and why? So we actually had some debate about this, right? Because arithmetic means adding or subtracting. So 3, 3, 3, 3, 3 would be adding a 0 or subtracting a 0. But that's actually not a sequence. It's not working quite right. Not adding is the sequence geometric, right? I could multiply by 1, right? That's not a sequence either, right? We have to have some difference or ratio besides those 1s and 0s. So it's kind of a extra question there. All right, so that was 18 minutes to get through the first 6 questions. I'm going to do another video for some of these other solving ones. Again, I may not do all of them because there's so many, but maybe at least pick a hard one or two and we'll put them up there.